Okay, a single 9-volt cell, known as a transistor battery that we're using, it can power a lot of different things. But eventually, you'll need more power. You'll need more voltage. And you can combine these. You've seen them in flashlights where they have the cells end to end. Or even a larger thing, I have a Coleman lantern that has 12 D cells in it. So it runs off at 12 volts. So you can have those type of setups. And I will show you how that works. Setting them up in a different configuration, you can get more voltage from the battery, or you can get less voltage from the battery. And then you can also change the current, because some circuits, and this is something to take note of, all circuits will draw as much amperage as they need to operate. So if you have a battery that only puts out a few amps, you may have to add another battery. But if, say, it runs on 9 volts and you add another battery, you'll double the voltage if it's put in what is called series. If it's put in what is called parallel, you'll add the amperage without adding the voltage. Right now I want to show you how to configure your cells to increase voltage or decrease voltage, or keep the same voltage and increase amperage. Okay, let's see what happens to batteries when you configure them in different ways. Parallel and series. We stick our batteries, tape them to the cookie sheet so they don't slide around. And then we place this piece of cardboard, it's actually a piece of paper under there, because we don't want our alligator clips to touch the cookie sheet. Otherwise you'll just have a short circuit. And here we hook up the negative to the one positive to the one negative, and then we'll hook the other negative to ground. So we'll hook that to ground. Then, so we have all three of these. We make sure that they're not touching the cookie sheet. Now our load for this is going to be a meter. It's a multimeter, measures voltage and amperage and ohms and on AC voltage, DC voltage. So we'll set that up. We'll turn it to 20 volts since both batteries together are, each one is 9 volts. They're both going to be about 18 volts or more, because they could be over 9 volts. They don't have to be exact. Now the little V is for voltage. The line was for direct current, and those little lightning bolts are for AC. So we're on DC 20 volts. Now is what I want to do before I take this, I should have done it before I hooked up, is measure the voltage of the individual batteries. So I unhook the one alligator clip, and we have on one battery 9.63 volts, and the other one is 9.70. Now we'll rehook that clip back up and take our voltage reading. Again, these are batteries in series. And it is 19.30 volts. Now we're going to pull this probe out and move it over to amperage to measure amps. That's a 10 amp, the 10 amp port, and we're going to change the switch over to 10 amps. We're not going to get 10 amps, but the other measurements are in milliamps, so I'm going to start with the largest. If it doesn't read it, I'll move down. And we are at 0.53 is actually what we had. We were at 0.53 amps. Now we're going to reconnect our batteries to reconfigure it for a parallel configuration. So what we do is hook up the two negative terminals to each other and the two positive terminals to each other. We've moved our probe there back to voltage because we're going to measure voltage. Want to make sure that none of these clips are touching each other. And we need to move the ground clip over to the positive. And then we will measure it. We have to flip our probes around. It's not that important. Okay, so we'll take our measurement, and it is 9.44 volts. So that's about what the two batteries were each, were a little over 9 volts. So you can see that the batteries in parallel do not add up on voltage, but on current they will. They should. So we move that over to our amperage. And we take our measurement. Comes out to 118. Okay, we connected our two batteries to the same pole, positive to positive, and then the negative to ground. And we'll see what the voltage comes out. Remember, these are a little over 9 volts each. So here we go, touching the negative probe to the negative, and then the red one to there, and we got 0.17. If you liked it, please like it, and please subscribe, and thank you for watching.